Okay, in this video, we want to solve this practice question for the JEE Advanced Math Integral questions, right? So it's a definite integral question, actually. So we have to find the integral from 0 to infinity of x times the logarithm of x at the top divided by the square of 1 plus x squared. And we have to do that with respect to x, okay? So let's see. Well, while I was practicing this, all right, I got a result, and the result was really annoying. You will see. So let's see. We start off by substitution. Okay, u sub. I'll say let's make u to be just 1 over x, right? Just a very simple substitution. So when that happens, we're going to see that the derivative of u with respect to x will be negative 1 over x squared, all right? That is just by using the power rule, and then we can put the dx over here. All right, so you notice this is a definite integral, meaning that we have to look at the bounds of the integration. So we have when x is 0, well, if x is 0, we can't just evaluate u at 0. So we need to look at the limit. So we look at the limit as x tends to 0 of 1 over x, right? And of course, this right here will be approaching, well, x is approaching 0 from the right, because this 0 is the lower bound. So we are approaching 0 from the right. This will be approaching infinity, okay? We also look at the limit as x tends to infinity. Of course, that is always from the left, of 1 over x. This right here is going to be just 0 and 0 from the right. All right, so we have that, which tells us that here we are going to be looking at infinity, and then at the top we'll be looking at just 0. So this can transform this integral into excuse me. Okay, so this will become the integral. Well, from 0, that will be from infinity to infinity, that will be to 0 of, well, x is said to be 1, u is said to be 1 over x, meaning that x will be 1 over u. Okay, then the logarithm of, well, in place of x, we're going to put in 1 over u, and then we divide that by, you notice that, let me put this logarithm in blue. Notice that this is 1 plus, right, x squared. X is 1 over u. So 1 over u squared, that is 1 over u. And then you square that, and then you take that raised to power 2, right? And then dx. Well, dx is going to be, you notice that this is du is negative 1 over x squared, which is just like saying that dx will be x squared times du, right? Negative x squared times du. And then x is said to be 1 over u. So in fact, in place of x squared, we're going to put in 1 over u squared, right? Just from the substitution. Okay, very nice. Now you notice that the bounds of integral are not really looking great. The reason is we are supposed to be approaching 0 from the right, but 0 from the right is outside this range, so we need to use the negative sign to correct that. That means we're going to have the integral from 0 to infinity, all right? Because this is a negative 1 as a constant multiple, and then this will multiply to the top. 1 over u squared times 1 over u will be 1 over u to the third power. So I'm going to put it down here, 1 over u to the third power. Then we have the logarithm of, where you notice 1 over u can be written as u to the negative 1 power, right? Okay, great. So we have that divided by, well, I'm going to expand this denominator a little bit. And when we expand that, we're going to have 1 plus 2 times 1 over u squared, all right, plus 1 over u to the fourth power. And then we put the du over here. Okay, that's very nice. Now let's see what we have. Well, this is the same thing as, well, what I'll do is to take this negative exponent, negative power here, out of the logarithmic term, all right? And then we are going to multiply top and bottom by u to the power 4. So we're going to have the integral from 0 to infinity of, when you multiply the numerator by u to the power 4, you're just going to have u left there, right? Let's put this well. Just going to have u left here. Together with this negative sign, then we're left with logarithm of u. Then we divide that by, well, we multiply the denominator also by u to the fourth power. You notice this is going to be 1 here. Okay, so when we multiply that, we're going to have 1 plus, we multiply with this term, we have 2u squared. Then plus, we multiply with this term, we're going to have u to the fourth power. And then we can put the du over here. Okay, that's very nice. Now you notice that this is the same thing as, well, let's call this negative u, negative times the integral from 0 to infinity of u times the logarithm of u at the top, all right, divided by, now this denominator is exact same thing as the square of 1 plus u squared. That is to say, this denominator is the same thing as 1 plus u squared, and then the square of that. So you notice if you square 1, you're going to have 1 plus 2 times u squared plus u to the 4th. Okay, great. So we can put the du over here. Now notice something. This is the integral from 0 to infinity of u times the logarithm of u divided by 1 plus u squared and then the square of that. In fact, it has the same function as that. It's just that this u is replaced by x. But since we are dealing with definite integral from 0 to infinity, in fact, the variable we are looking at, it doesn't really matter, okay? Because in this case, these are like dummy variables. Okay, so we can change u to x if you like. They remain the same because the value of a definite integral is always a number. Like a definite integral always gives a number. So it will give you the exact same thing as that. Just that this one will be with a negative sign. So in fact, I would like to call this a name. Let's call this I. Okay, let's call that integral the I. Oh, it's not really showing. So as you can see, that tells us, let me clean from here to the second to the last line, and then we're going to see what I'm talking about. Okay, so as you can see, the integral question we're given, that is the integral from 0 to infinity, which I've written out here, of x times the logarithm of x divided by 1 plus x squared. We ended here by saying it is the same thing as the negative of integral from 0 to infinity of u times the logarithm of u divided by 1 plus u squared and then the square of that. So as you can see, this right here is almost the same thing as that, except for the negative sign and except for the variables. But as I said earlier, when we are looking at a definite integral, in fact, the variable we are considering is just like a dummy variable. We can use anything we want, okay? Just x, we can use u, we can use y, we can use whatever. Given that, because the definite integral always produces a number. So in fact, this right here can be replaced by x, okay? So I can change this to x. Let me use a red for that. Can change this to x, okay? It's the same thing to x and then this to x, right? We haven't almost changed anything, right? Apart from changing that to x. So in fact, what I'm going to do is to add this to both sides. We are going to have 2 times, okay? 2 times the integral from 0 to infinity of x times the logarithm of x at the top divided by 1 plus x squared and then the square of that dx. And when we add this to both sides, this means the right hand side is just going to be 0. This is where it gets annoying, right? Okay, so let's do what we asked to find. We asked to find this integral. That means we just have to divide both sides by 2. So we're going to have the integral from 0 to infinity of x times the logarithm of x, right? Over 1 plus x squared and then the square of that dx is just 0 divided by 2, which is just 0. This right here, in fact, is the result. The answer is just 0. After everything, just 0. Anyway, I was expecting something greater, right? Something better. But there's nothing we can do, right? So the integral from 0 to infinity of this function just gives us 0. Anyway, that's it. Alright, thanks for watching and please subscribe to my channel.